Hello everyone, welcome back to MAT1033. So far you guys already learned how to solve linear inequality, and you know how to express your answer using interval notation and the number line. Now, what if I have more than one inequality, okay, and I want to combine them together? Okay, more than one, what I mean is this: it could be two inequality or three inequality, and I want to combine them together. And after we combine them together, we can create another type of inequality. It's very special inequality we call the compound inequality. So in this video, I want to discuss and we want to talk about how to solve a compound inequality and what compound inequality look like. Okay, so let's get started. Alright, so let's put the topic today. Compound inequality. Okay. Alright. Before we jump to the method of solving compound inequality and what compound inequality look like, I just want to do a quick review on two concepts, and maybe some of you already know it, some of you have been very familiar to it, but I'm sure that many of you have forgot. The first concept I want to do a recall. Okay, is this the intersection? Okay, intersection concept. What does it mean by intersection? Intersection between what? Intersection between two sets, right? Intersection between two sets. Well, what is set? What is set? So maybe before the concept of intersection and the concept of the second concept I want to recall, I think it is union. The second concept is union. But before we learn that, before we do quick recall on that, let's talk about the set. What is set? What is set? So maybe I'm gonna start with the definition of set first. Okay. Let me start with the definition of set first. Then we're gonna talk about intersection and union. Set. What is set? Alright. A set is a collection. Okay, it's a collection of items. Okay, it's a collection of items. And items over here, what I mean over here could be anything. It could be a collection of number, a collection of color, collection of furniture, or anything. Collection of items, collection of things. Many different types of things. Okay, for example, I can give you example of a set like this. For example, I can create a set A. Okay, a set A over here is with a curve bracket like this, and this set over here include the first. This set over here is include the first 10 positive integer. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a set. This is a set of the first 10 integer, positive integer. Okay. Okay, I just create a set. Excuse me. Or I can create a set of I'm gonna call it set D. Okay. I can create a set of what? A set of odd number. For example, like 1, 3, 5, 7, and so on. So the difference between set A and set B over here, set A is over here, we have a limited number of items. So this is countable set. and this is uncountable set because there's so many odd number we cannot even count it. So that's what we call an uncountable set. Or I can create a set of a set C over here. I can create a set of what? A set of how about a set of color four color, for example, like blue, green, white, and yellow, for example. So I have a set of 4 different colors, or I can create a set of a set D over here. I can create a set of furniture, maybe like bed, chair, you know, or what, or a bed, chair, or table, or wardrobe, or something like that. Okay, wardrobe, something like that. So you see, you can create a different type of set if you want it. Okay, and the set could be countable or uncountable. In this case, for set A, set B is uncountable. So this is uncountable set. Okay. All this, the other set over here is countable. And over here, the first set we have 10 items, and the set C and set D over here we have only 4 items. So that's the quick recall, a quick review on what set is. So now, after we learn what set is already, I want to talk about the concept of intersection. Okay, the second part, intersection and union. Intersection and union. So first of all, let's talk about intersection. Intersection between 2 sets. That's what or intersection amongst the sets. So I'm gonna add a little bit more. So amongst the set, or it could be intersection amongst interval. Okay. Okay, but what is intersection? What is intersection? And what is the notation for intersection? Okay, intersection, it means that we try to find the part that in common. So intersection means finding parts share in common. Okay, in common with amongst the set or amongst the interval. And the notation for intersection will be the letter U upside down like this. There you go. So this is mean intersection. Okay, even that you want to find the part that share in common, like the part that both of the set have it, or the part that both interval have it. Just all the item or the things or any anything that's share in common, they belong to intersection set. Okay, if I go ahead and draw the picture, this picture we call it the Venn diagram. For example, I have 2 sets like this, and I call over here set A. And over here set B right here, and you see that the 2 circles overlap each other, right? And when it's overlapping each other, so this is the intersection. There you go. So the part right here is intersection. Okay, so the intersection over here is actually a set. It's also a set. So this is also a set. Okay, it's also a set. Right here is also a set. So it means what? It means that if we have set A and we intersect with set B, then it gives you another set. It gives you another set. So this is the intersection part right here is also the set. All right. I don't want to go too deeply into the theory of the set. So I'm gonna just stop right here and give you an example right away. example number 1. Okay. What if I have two sets like this? Set A we have like 1, 2, 5, 7, 9. Okay, and set B I have 3, 5, 7, 10, 12. Okay, and I want to find intersection between between set A and set B. Then intersection between A and B, and because this is also this intersection is a set, so that's why we also have to use the curve bracket. So we try to find something in common here. Try to find something in common. So what numbers in common? What element? Okay, what elements in common? So 5, right? 5 in common, right? And 7 in common. Okay, 7 in common. Okay, so intersection set has 5 and 7. Okay, so this one intersection set has 2 elements. Okay, that's how you find intersection. You try to find something in common. Okay, how about this one? Example 2. What if I have 2 interval? For example, I have interval. How about I have negative infinity to 5 bracket, and I want to find intersection. I want to intersect them. Okay, to another interval. For example, like 1 to positive infinity. Okay. If you're really good, you can go ahead and graph the number line. Okay, draw the number line. Right away. Intersection between 2 interval is an interval. So you have interval here and intersect with another interval. So your answer must have an interval. Okay. I mean, some of you are really good and you can see right away. But if you cannot see it, you go ahead and draw the number line. Okay. So go ahead and draw the number line with me. So I'm going to go ahead and draw the number line. Oops. So I'm going to go ahead and draw the number line. Here you go. I draw the first number line representing the first interval notation. So it's negative infinity, positive infinity. Let's go from negative infinity to 5. So 0 over here, 5 up here. Okay. 0 right here. Okay. And we want to include 5. So this is open circle. Right? It's open circle because we want to include 5. We use different color. So we want to include 5, and because it's from negative infinity to 5, so we're going to set this part. Set this. Okay. There you go. Alright, that is the number line, and this is the number line for the first interval. Now let's do the second one. Do the second one. It's negative infinity here, positive infinity here, and 0 right here. Huh? 0 still here. So 1 is here, 1 here. Okay, and we want to shed where? We want to shed. Let me pick this one right here. We want to shed everything to the right. Huh? Okay, everything to the right. There you go. Alright, so based on this number line, these 2 number line here, we can try to find. We're going to try to find the intersection part. Okay, we try to find the intersection part. The part, finding the part. Find the part. Find a region. Find a region where yellow, okay, and blue share income. Share income. So where's that? Where's that? I don't know. You can see that. So it's right here, right? It's right over here. Here and here, right? So basically, right over here. So I go ahead and make a color right here so that you can see it. Here you go, right over here. So the final answer for this will be what? Will be 1 not included, right? 2 5 included. There you go. Alright, so that's how you find intersection between two intervals. And you do the same thing if you have 3 intervals, 4 intervals, 5, or many different intervals. You can find the intersection also. Okay. So that in intersection concept. Now, how about union? How about union? Be union. So what is union? What is union? Union, it means that you're gonna take everything. Okay, whatever you said, you take it. Okay, union, it means you find everything, every part of the every part of interval or element or set. Okay, and the notation for union will be the letter U like this. Okay, it's a letter U. Okay. Now, and I can go ahead and draw the picture so that you can see. I have 2 pictures like this, and I have 2 set of A and B like that, and the first one, let me use the green one here. Okay, and the blue one. Okay, let me use the blue one. There you go. Okay, that's the blue one. So you see that the green and the blue is kind of overlapping each other. So, but we don't care about the overlapping part. Okay, so we care about everything. So in the union, union between A and B will be everything you said. Okay, and everything you said is also the set. So union is also the set. Union is also a set. Okay, it's also a set. All right. Now, let me jump to the example so that you can understand more. Again, I don't want to go too much theoretically over here. So, what if I give you 2 set A and B like this? I have 1, 2, 3, and set B is like 2, 3, 4, 5. Okay, so I can find a union between A and B will be what? Will be everything. Of course, you see that the 2 and 3 is repeated, it's overlapping, but we don't find the intersection. We take everything. 2, 1, 2, 3, 4, 5. There you go. That's what it means. That's what union is. Okay. How about this one? Let's deal with interval notation. What if I have -1, 2, 6? Okay. And I want to find union of this interval with 4 to infinity. Alright. Again, if you're really good, you know right away the answer. But if you're not really that good, so you just can go ahead and draw the picture. Draw the number line. Alright, go ahead and draw the number line. Infinity here, positive infinity here. So -1, 0 right here, -1 over here. is included, right? And 6 up here. Alright, so let me use different color. It's included. It's included. Alright, so I shade it. Okay, between -1 and 6. That's for the first interval. Now for the second interval, same thing. Okay, but we're gonna go from 4 to, so 0 right here, 0 still here, 4 up here, 4 here, and we included 4, huh? We included 4. So so we're gonna have 4. Oops. Oops. So I'm gonna go back. Sorry, something not dry. This is it's not the color I want. Let me see. Here, maybe we should use this. Alright, so red. Let's do the red. Okay. So I don't know how I'm gonna delete this one. I'm gonna delete this. Let me see. Eraser. Let me see. It's not working. I don't know how. Here you go. I can delete it now. Okay. So this. Okay. So let's redraw this. This is 4 here, and we want to include 4. Okay. So it's 4 right here. Okay, and we shade it. Right. There you go. Now think about it. If I go ahead and find intersection, I mean that this is where the blue and the red overlapping, right? But we not. We take everything. If a union, it means you take everything. So you take everything. It means that you're gonna go from where? From -1 included, huh? To what? To infinity. Okay, we not stopping at 6, but because you said that the red one, the red part right here is keep extending to infinity. So to infinity. There you go. That's how you find a union. Okay, pretty easy, very straightforward. No trick over here. Okay. Okay, so after you already know what union and intersection is, now we're going to jump to our main part of the lecture today, which is compound inequality. The reason we have to review intersection and union because think about it, we have compound inequality, as I said, is this combination between more than one inequality. Inequality is an interval notation. It means that we have to find intersection between two inequality. Okay, find intersection. Okay, between two inequality. Okay. All right. Now let's start with our third part of Roman. Okay. Compound inequality. Compound inequality. Okay. So first of all, let's talk about the definition. What is compound inequality? We need to understand what it means first. Okay, what it look like first. So compound inequality is a combination. It's a combination of more than one inequality. Okay. So compound inequality must be an inequality. It means that the solution, okay, the solution of compound inequality is not one solution. The solution contain infinitely many value. Okay, so how are we gonna find a compound? How we find a solution of compound inequality? The general method of finding the solution of compound inequality, it is to solve each inequality. Okay, so it's inequality. Then find intersection. Find intersection. Okay, between interval. Okay, between interval. Alright, for example, I have something like this. So I have okay. Hold on. Before I jump to the example, okay, I want to add a little bit more. So because it's a combination of more than one inequality, and how they gonna combine it? How they combine it? So they combine the inequality combined by using okay union and in or intersection. Okay, by using intersection or union. Okay, and we already talked about union and intersection already. Okay, or sometimes they use or and. So union, it means this is mean or, and intersection, this is mean and. Okay, this symbol over here mean is equivalent. Okay, intersection mean and union mean or. For example, now let's jump to the first example. I have sorry, I still have allergy. I have the first linear inequality, something like this. I have like 2x plus 1 greater than 5, and I combine with another inequality, and I combine over here using n. Okay, and I combine with the second inequality. In this case, for example, I put x minus 1 less than 4. Okay, so in this case, so you see that in this case we have to find the intersection between the interval right here. Okay, I'm gonna add a little bit over here for the general method, because sometimes the question is instead of and is or, so I'm gonna put over here find union, okay, amongst interval. Okay, so I'm going to change this a little bit, should be amongst. Okay, so I'm going to solve each of them. Okay, so I'm going to solve each of them over here. So I solve it. This is give you a 4, huh? So everybody already watched the first video and already how to solve linear inequality. So x greater than 2, and this is x less than 5. Alright, now if I go ahead and put it on interval notation, then what you have 2 to infinity, right? And it mean what? And mean intersection. Yeah, intersection negative infinity to 5. But that is not the final answer. Okay, because we gotta find the intersection here. Alright. So I'm gonna put it on a number line, and in this case I'm gonna put it just in one number line only, because we want to find intersection. It means we want to find all the two different colors overlapping each other. So it will be 0 here and 0 here and 2 here and 5 here. This go from 2 to infinity. So let me use the green one. 2 to infinity. There you go like that. Okay, and the other one, let me use the purple one. Negative infinity to 5, so 5 right here. There you go. Alright, now let's go ahead and read this. Where is the blue and the green part overlapping? It's right over here. Right over here, right? Right over here. So it means that the final answer will be what? The final answer will be, the final interval will be what? Negative infinity. Negative 2, I'm sorry. Is that 2? Oh, it's 2, I'm sorry. 2 to 5. Sorry. Because it's overlapping. You see the blue and the green and the purple over here overlapping each other. So it starts from 2 to 5. overlapping, because original question is and, it's intersection. We want to find intersection part. Okay. All right. Now let's do another one. Example 2. Now let's try to find something with union. Okay. Mm, mm, try to find something with union. How about like this? I have 3x minus 1 plus 4 greater than 6 union with or x plus 3 less than 3x minus 1, for example. Alright, so I combine two inequalities together and go ahead and solve each of them. So everybody know how to solve this. So greater than 6, so x greater than 5, x greater than 5 over 3. And this is what to give you. This is x plus 4 less than 3x. So 4 less than 2x, mean 2x greater than 4, right? X greater than 2, alright? And we want to find R, huh? We want to find R. So we go ahead and put in interval notation first. So this is greater than 5 over 3. I think I'm going to go ahead and change a little bit here into equal. Just change a little bit, okay? So over here it means that we're going to go from 5 over 3 bracket to infinity. And because R, so we're going to do union greater than 2, so 2 to infinity. But you have to be careful again. This is not the final answer yet, so we gotta go ahead and put it on the number line. Alright, so for this one, we're gonna put we're gonna use two number line. Each represent for each in the interval right here. So 5 over 3 about 1 point something. So this 5 over 3. Okay, and this should be the close bracket. Here you go. I'm going to do green right here. Okay. And how about 2? Number 2. Okay. 2 should be on the right hand side of 5 over 3, huh? So 2 should be over here. And it's open circle. And we go from where? We go from 2 to infinity. There you go. Alright, but we want to check the union. Union means we check everything. It doesn't matter. Okay? It doesn't matter. We check everything. It means the final answer will be what? Alright. Final answer will be what? Final answer will be from 5 over 3, right, bracket, to infinity. Okay? We check everything. Okay? This part overlapping, but we don't care. Okay? This part, even though they don't have it here, but up here we have still set it, even though it's not setting here, but that's okay. We check everything. Okay? Whatever you set, you check it. Okay? Whatever you say, you check. That means union. Okay? Now, there's some cases, some cases like when you have two linear inequalities combined. Okay? You combine them together, and at the end, okay, your answer is not just one interval notation. So sitting in example 1 and example 2, okay, the answer is just one interval notation. But sometimes the answer is not just one interval notation. The answer could have more than one interval notation. So in that case, you have to use union to write final answer. Okay, let me see. I can come up with another example in for that case or not. How about something like this? Have let me see. What if over here I have I have I'm trying to make up an example here. So let me see. What if I have okay, how about this? What if I have x less than -5? Okay. Um, okay. Or x greater than 5. Okay. Okay. And I'm gonna intersect this compound inequality, okay, with another one. For example, like uh, uh, so I'm gonna combine. I'm gonna find intersection between this compound inequality with another inequality. In this case, is how about um, how about I don't know. Let me see. 5. How about the interval? I try to find intersection. So I try to find intersection. Intersection with the interval negative -7 and 8, for example. Okay, it's 7 and 8. So how we do this? How we find intersection here? So first of all, go ahead and draw the number line, because we don't have to calculate anything here. We don't have to solve anything because already been solved for us. So go ahead and draw the number line. Okay, and then 5 right here, 5 right here, infinity right here. So if we go ahead and shade it, so this will be this is what we shaded. Okay. Okay. Now how about the second one? How about the second one? Here, here. -7 is all the way over here, and 8 is up here, and with 8, um, we want to include it, and 7 we don't want to include it, and this is mean between -7 and 8, so I'm going to set everything in between. So you want to find the intersection. It means that you want to find where the yellow and the blue overlapping each other. So this is where it's overlapping, right? This is where it's overlapping, and here and here. Okay. So it means what? It means that you have two parts is overlapping, not just one part. So the final answer will be what? Answer will be -7, not included, to 5, not included. And you have another one, right? You have another one, which is 5 to 8. Alright, so when you have two intervals as the final answer, and you have to connect them together. How are we going to connect them? You have to use union to connect. Always. Okay? always. So I'm going to put a remark over here. Okay, if having more than one interval as the final answer, you must use union to connect them. Okay, you must use union to connect them. Alright, it's very important point right there. Okay, so make sure you remember that. Okay, now for the next example, I'm going to give you something, and this is very special compound inequality because they're not using and or. They're gonna write something like this: negative 2 less than 2x plus 5 less than 2. This is also the compound inequality. This is called a double compound inequality. And maybe you kind of ask me like, Mr. Win just say that, okay, in order to be called compound, it must have union and intersection. And over here, we don't have intersection and union at all. Okay, so in this case, what we're gonna do? This is still called compound inequality. Okay, it's still called compound inequality because this has the same meaning as negative 2 less than 2x plus 5 and 2x plus 5 less than 2. So they don't want to write like this because it takes too long, and there's a short way of writing this compound inequality here to this. Okay, got it? So how we're going to solve it? You just go ahead and subtract both sides by 5, so you use negative 7 less than negative 3, and you divide it by 2, so negative 7 over 2 less than x less than negative 3 over 2. Then you have the interval notation will be what? Will be parentheses, right? Negative 7 over 2, comma, negative 3 over 2. That's your final answer. That's your final answer. Okay. So actually it's in between. So 2 less than inequality sign over here tell you that it's in between. Okay. So but that is for the case when you have no variable on the left and the right hand side. You just see the variable in the middle. You don't see variable on the left and the right hand side. What if they have variable on the left and the right hand side? What if I have something like this? What if I have x plus 1 less than 3x plus 5 less than x minus 4? So in this case it will be harder. And in this case you have to split them up. So you gotta go ahead and split up into two cases using n. Okay, you gotta split it up. And we solve it. So I'll give you negative 2x less than 4, x greater than, divided by negative greater than negative 2, 2x less than negative 9, and x less than negative 9 over 2. Okay, and because this is n, so we have to use intersection because this is not a final answer yet. It's not a final answer yet. So go ahead and put it on the number line. Alright, on the number line. So in this case I'm going to put in two different number lines so that you can see better. So negative 2 here is 0 right here, and maybe I'm going to change a little bit here. So we put an equal so that it's have more fun. Okay, so this is a close bracket. Close bracket. So I'm going to use close bracket. I'm going to shade everything to the right. Okay. Now let's do for the second number line. Negative 9/2 is all the way over here, right? And let me use this color here. Okay, so this open circle, and I shade it over here, right? Alright. Now we want to find intersection. Anyone can tell me where's the purple and the green overlapping? Oh, we don't have anything overlapping, right? It's not even overlapping, right? It's not even overlapping. So it means that we don't have anything overlapping. We don't have anything overlapping. It means we don't have any element, any point, any value in common. So it means what? It means the final answer for this compound inequality will be no solution. Okay. So just think about it. If you just go ahead and stop right over here as the final answer, it means that you're missing something really big. Right? Missing a very big part, very important part. Because it's not the answer. It's not the final answer. The final answer over here is no solution. Because there's nothing in common. Okay? And to make sure that you have to go ahead and split them up when you have a variable on different side. Like this. But in example 4, you don't have to split them. You can go ahead and solve it right away. Okay? Alright. Later on, when you go to higher level in college math algebra, we just go ahead and put the absolute value over here and require you to do more stuff, more intersection, more union. So as long as you really understand all the example in this video, I'm sure that when you go to higher level college algebra pre-calculus, you should be okay. Okay. So please go ahead and watch the video carefully. Let me know if you have any concern, any question. Do not hesitate. Send me a message to Canvas, and I will try to explain any part you not get it. But I think that the video is clear enough, and I'm sure that is enough for you to understand and in order for you to do homework. And I'll see you next time. Bye bye.